Let's go on page 37 when we're done. All right, 37, everybody. Okay, so remember, if we have a rational function that is made up of a ratio of two polynomial functions, if g of c equals 0, okay, that just means g of some number equals 0. That makes the denominator equal 0. So that means that h of x has a vertical asymptote or a hole at x equals c. Don't let all the variables make your head hurt, okay? C is just some number. We don't know what. Yes, we use x as some number, but we're saying x is a constant. X is not anything other than that, all right? So if we have, says let h of x equal this function here, we're going to write an equation in factored form and find any values of x where h of x has a hole or vertical asymptote. Okay, so factored form, h of x equals, and this would be x plus 2 times x minus 2. And then down here, x and x. 10 is positive, so the signs are the same. 7 is positive, so it's positive, positive. And what are my two numbers? 5 and 2. 5 and 2. So there is my factored form. Okay. Then it asks me for any holes. Am I going to have any holes? Yes, because I can reduce that, and it's at x equals -2. Now, when we were doing these before, we were substituting it back in, getting the whole ordered pair, right? Which is something we need to know how to do. But this says find any values of x. That's all it's asking me for. That's all I'm going to do. Okay. If I need to go back and for some other reason, I can go back and do that. So I have this x plus 5 left over here. So that means I have a vertical asymptote at x equals -5. Okay. So when we talked about domain earlier, domain, what we put in our notes is we do domain first. It's before we cancel anything out. Well, I know I already canceled it out, but I haven't rewritten it as the reduced form, so I can still look at this. Even if I don't have this function at all written, but I know these two things, I can still do my domain. Because the domain is everything that, all real numbers except for what makes the denominator 0. And these are the two things that would make my denominator 0. So now I can write my domain. I'm starting at -infinity. I'm going to go all the way to -5, skip over -5, go to -2, skip over -2, and go to infinity. Okay. We good with that? You see how easy that is? Everything except for what makes the denominator 0. We just skip right over them. Should be no brackets anywhere. Everybody good so far? All right. Example 3. We have k of x here. We want to write k of x in factored form. So I'm going to go ahead and write underneath it. I can tell the denominator has a GCF, so I'm going to factor that out. That leaves me with x squared plus x minus 20. Then I can do k of x equals, all right, numerator. Got two factors, x and x. 12 is negative, so the signs are opposite. What is the positive number? 3. And this would be 4. I factored out that x. I can't forget about him. He's got to be along for the ride here. X and x, 20 is negative, so the signs are opposite. What's my positive number? 5. Okay. So there is my factored form. Now, the next thing that I'm asked for are my zeros. The zeros come from where? The top, the numerator. All right. Open your ISN to page 31. Okay. If you look at the front of your notes on 31, It says that we do the, we find the zeros when? After reducing. Have we reduced yet? No. When we reduce, what do we find? The wholes. So let's, before we worry about, even though this is the next question, I'm going to do this part next, because remember, that's the first thing we do is find our wholes, then worry about everything else. So I'm going to cancel this out, which means I have a whole at where? X equals 4. Yes. So now my reduced version, get x plus 3 over x times x plus 5. Here is where I look when I look for my zeros. If I do it before I reduce, I might want to use 4 as a 0, and 4 is not a 0. Okay, we good with that? So negative 3 is the only one that I have. X equals negative 3. Okay, everybody good with that? All right. Then we find any vertical asymptotes. I'm using my reduced function for that as well, because on vertical asymptotes on your notes, it says after reducing, right? And how many vertical asymptotes would I have? 2. Got 1 at x equals 0. Y'all always want to forget about 0 and negative 5. Notice that they have to be written as 2 separate things because those are equations of lines. If I have multiple zeros, I can do x equals 1, 2, 3. That's all fine and great because that's a list of numbers. These are equations, even though they don't always look like it. Okay? All right, then horizontal asymptotes. Are we top heavy, bottom heavy, or tied in degree? Bottom heavy. So my horizontal asymptote is? Y equals 0. Where are you getting 1 over 2, dude? No, the coefficients when they're tied in degree. You're mixing them all up. All right, now on page 31, when does it say to do domain? First, before we reduce. Oops. Okay, so you can do that. I can look back up at this pink one, or, and because we hadn't talked about all this yet, again, the domain is everything except for what makes the denominator 0. These are the 2 things that make the denominator 0. So these are the 3 x values that I cannot have in there, which I can still see in my denominator here. But if I use my reduced version, I don't see the 4 in there, right? So that's why it says before reducing / you can use the wholes in the vertical asymptotes. It really doesn't matter. So this one, we're going to start at negative infinity, go to negative 5, skip over negative 5, go to 0, skip over 0, go to 4, skip over 4, go to infinity. Okay, everybody good? Questions? All right, so now it tells me to sketch my graph. All right, so let's put some stuff on here. Let's start with the things that we know. So the first thing that we have in our little list of stuff is that we have a 0 at negative 3. So I can put a 0 at negative 3. Then the next thing is that I have a whole at 4. Where at 4? We don't know. Can we find it? Yes, they didn't actually ask us for it. They only asked us for the x value, but we can find the y value. We just haven't yet, right? I can plug it in. Yes, we plug it into the reduced one. So I need to find k of 4 because I'm trying to find the y value of the whole. That's going to give me 4 plus 3 over 4 times 4 plus 5. So that gives me 7 over 36. So this is 4, 7 over 36. So that is an ugly fraction. And this would totally be non-calculator everything. But I need a reasonable estimate for that so that I can graph it. Now, 7 and 36 don't divide evenly, or I'd be able to reduce it. But what does 7 divide into that's really close to 36? 35. Oh, sorry. 35. Yeah. 35. And so if we pretend like that's 35, then it would reduce to 1/5, right? And a little bit of pretending is okay when we're estimating because we got a little grid and we can only get so close to 1/5 anyway, right? But 1/5 makes more sense in your brain than 7/36, right? So we're going to think 1/5. So we're going to go over here and go to 4. 1, 2, 3, 4, and then make a little hole. Well, the best you can. My pen's real thick, so See, it's so far off of where 1/5 really would. It's just kind of right there, right? Everybody okay with that? All right, so then the next thing we have is vertical asymptotes. So I have vertical asymptotes at 0 and at -5. And then I have a horizontal asymptote at y = 0. Okay. All right. So here's what I know. I only have 1 point, or actually 2 points that are actually plotted. And I need to figure out what the heck to do with this graph. Here's what I know about this middle piece here, is that I have to go through this point. So I either am hugging the asymptote up here and coming down like this, or I'm hugging it down here and coming up like that, because I can't poke through, right? And on either side of any of the vertical asymptotes, I'm either heading to infinity or negative infinity. What can I do to help me figure out which way I'm going? The sign chart. Good, the sign chart. It's what? Well, yes, but I don't have the limit statement. And in order for me to write a correct one, I still need my sign chart. So I still got to do the sign chart. Yes, well, maybe it's this.
Oh, the number line.
Yeah, the number line. Yeah, number line, sign chart. Okay, I'm going to rewrite this because I can't see it. I can't see it. It's up there. So what I have on my number line is a -5, a -3, and a 0. No. Yes. Yeah, that's right. Okay, sorry. All right, and then what I know also is that my asymptotes are here at -5 and at 0. Okay. So I'm going to pick something to the left of -5, like -6. So that would give me negative, negative, negative. That's negative overall. All right. So let me let you in on a little secret, okay? Which hopefully I'm not letting you in on this secret a little too soon. If you've noticed when we've done these sign charts, sometimes they just alternate, right? And sometimes they don't. They don't alternate if you have a term that is squared. If the term is squared in the numerator, that's when we have the tangency and it bounces. So if it's positive, then it hits and it stays positive, right? If they go in the same direction on either side of the asymptote, that's called togetherness, and that would be if the denominator was squared. So since I don't have any terms that are squared, after I have figured this one out and it's negative, they're going to alternate. Okay? And so just remember that they don't always alternate. And if you're ever in question about how it's supposed to alternate or what's happening or there, oh my God, there's a squared, then just go ahead and just do the whole sign chart. It won't kill you. All right? Some of you might want to always do the sign chart. That's totally fine. Like actually figure out the whole thing. Listen, if this was x plus 5 squared, then if this is negative, and then it would alternate. Okay? So what this is telling me here is that if this is negative, this is down here, this is up here, this is going down here, this is coming up here, like so. Okay? And this is where it has to cross the axis. So that's kind of pretty much my graph. Now, sometimes, and we're going to graph it better over there, but sometimes we don't have enough information to know whether or not we cross our horizontal asymptote. Here, I totally have enough information because my horizontal asymptote is at y = 0. So if it did cross the x-axis over here, then that would mean that I'd have to be positive, which it's not. So instead, we know that since this is going down here to negative infinity like this, that it looks something, well, that's not good. Something like this. Okay, never mind. I can't make them connect, so I'm just going to do it all at once. My hand gets in the way. Okay. And then since everything is alternating, we're alternating on either side of the asymptote as well. We know that this is coming up like this is going down like this, and then so then when we connect them, it's got to have a little point of inflection right there. Okay. And then from 0 to infinity, it's positive, so it's going to come down and go not through the 0, and it doesn't go through it, just kind of skips over the 0. I mean, over that hole. I'm sorry, not the 0. There is no 0. And that's how you can graph irrational when you have absolutely no idea what it would look like to begin with. Because like I've told you, I wouldn't know either without finding all that stuff. Okay. What questions you got? You have to learn it. You don't have to memorize anything. All right. Questions? We good? Flip it over. Now we're going to do the opposite. We have a graph. We're going to write an equation. We wrote some equations the other day from the limit statements. Here, it's a little bit more obvious what things are, I think. So this is f. So I'm having f of x. All right. So I'm just going to kind of start left to right. The first thing I come across that I know will help me. The first thing I see is that I have a vertical asymptote at 2. That means I would have a factor of x minus 2 where? Denominator. Okay. Okay, we good with that? The next thing I come across is this 0 at 3. So I would have an x minus 3 where? The top. Then I can see that I have a hole at 4. So I have x minus 4 where? Both. So this is x minus 4 and x minus 4. Everybody with me so far? Yeah. Okay. Now the other thing I have to take into account is my horizontal asymptote. My horizontal asymptote is right here at y equals -1. So should my function be top heavy, bottom heavy, or tied in degree? Tied. If you're at a number other than 0, it's tied. This one's tied, so I'm good. I don't have to like throw anything extra in there. But if I take the ratio of leading coefficients here, will I get -1? What do I get? 1. And so I need to put a negative here because what I need is the -1. Okay.
So like if it's top heavy, then it's
top heavy, it's a slant asymptote.
And then bottom heavy 0, and tied is -1.
Tied is the ratio of the leading coefficients, whatever they are. It could be 2/3, it could be 1/5. It depends on what the numbers are out front. Okay.
Bottom heavy, we won't have a horizontal vertical.
If it's bottom heavy, it's y equals 0.
Sorry.
It's top heavy, it wouldn't have a horizontal, it might have a slant. Yeah. All right, listen. I don't know for sure that, I mean, I need a ratio of -1. I could have -5 here and +5 here, or 7 and 7, or whatever that would make 1, but we don't have to get fancy. This is the best I can do. It's fine. Okay, we good on that? All right. All right, so I'm going to give you a minute. I want you to write out, this guy's name is G. So start putting some stuff in G of X. Pick up your pencil and write stuff down.
Is there not an asymptote?
It is.
Yeah, it's an asymptote.
Well, it's an asymptote. It's not an asymptote, but yes. I know. She's messed so many of y'all up. That's why she does it.
When she first says it, she says it. She said she makes sure to emphasize that we say it when we come here.
Yeah. I know. I know. I know.
I remember thinking.
What? Yeah.
Wait, how did you find the like the bridge?
Because, like, which one are you talking about?
So, like, how did you find the numbers? And then
Because I have a vertical asymptote at 2. That means I have a factor of x minus 2, and it has to be in the denominator.
So the vertical asymptote here is x at 3.
Uh-huh.
So then I have one of -3 on the top.
No, vertical asymptote comes from the bottom. Yes. Oh, hang on a second. I'm looking. You're missing something, but you're on the right track. You're just not finished. You're not wrong. You're just not finished. No, you're good. No, you're good. I was talking to her. Okay. All right. Let's talk about this, because even if you have all the parentheses and stuff in there, you may still be missing something. All right, so as I go from left to right, I see that I have a vertical asymptote at 0. That means I have an x in the denominator. To take care of my other vertical asymptote, I have one at 3, so that means I'd have an x minus 3 down here as well. Yeah, it's because you have to go by the way it's the shape. Yeah, because even though you can't, listen, you can't usually see the dashed lines when it's on an axis, but because of the behavior of the graph, you know that it has to be an asymptote. Okay. All right, so then I have a 0 at 1. So we got an x minus 1 here. And I've got a hole at 2. So I would have x minus 2 and x minus 2. Okay, so those are all the parentheses stuff I can put in there. Now, where's my horizontal asymptote? On the 0, on the bottom. It's y equals 0. So what do you mean on the bottom? On the bottom, sure. It's at y equals 0. So that means, should this be top heavy, bottom heavy, or tied in decree? Bottom heavy. And this is bottom heavy, right? What we don't know for sure is whether or not what we have written will actually make our function behave that way on either side of the asymptote. Like maybe it will be going to negative infinity. So how do I check the signs of my graph? The sign chart. Yeah. So on here, I have 4 things. I have 0, 1, 2, and 3. I really only care at the beginning about what's going on around 0. Because do I have anything? Well, on my graph, I don't have any bounces, right? So there's nothing squared in the numerator. I don't have any togetherness, so there's nothing squared in the denominator. So if I substitute in -1, that would give me negative, 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 negative. So this is negative overall, which means this will be positive, negative, positive, negative. But if you look at the graph, according to my sign chart, this is what my graph should be doing. Is that what's happening? No. So I need to reflect it, which means I need what in my equation? Negative. Okay.
I thought it was a 7.
Oh, what is? Oh, it's a 3. It's a weird looking 3. Sorry. Yeah. Yes, ma'am. When they go in the same togetherness would be this. Oh. Where they're going in the same direction on the other side of. Okay. We good? Questions? All right. Grab your other sheet of paper. Okay. We're going to talk about slant asymptotes again. I know, quiet. I know that it sounds like we're talking about the same thing over and over again every day. We kind of are. That's called practice. All right. We are, but a little bit different. So and this is a recall because we've talked about it multiple times. If the degree of the numerator is 1 greater than the degree of the denominator, then the rational function has a slant asymptote. What is another word for slant asymptote? Oblique. Yes. So I'm going to remind you about that every time, because if that word gets thrown at you, you need to know it means the same thing. It's not any more complicated. It's just a different way of saying it. So it depends on who said it, right? Okay. So we have this function k of x. Here it is factored. And we have a hole at x equals 2. And we have a vertical asymptote at -1. And it does not have a horizontal asymptote, but it does have a slant asymptote at y equals x plus 1. That is the entire equation. So remember, there's a difference between this is the slant asymptote, and this is the piece of it, the slant asymptote that will help me with end behavior. Okay? So again, it says the same thing. Since the degree of the numerator is 1 greater than the denominator, when we want to find it, we do long division. This right here is a little practice, but we've already practiced, so we're going to skip that. So flip that over. And then you're going to use it because you've already practiced. 2x plus, oh, I know. 2x plus 1 divided into 6x squared plus x plus 5. Make it happen. Yes. Don't tell me no. I've been doing this all day. You can do it once.
Oh, you have the name.
Yeah.
Sorry. No, it's not 6. It's 4.
3x minus 1?
Well, I got it, but I got the remainder of 6. The remainder of 4.
It's 6.
Oh.
The remainder is 6.
Hey, 'cause you took the sign.
All right. What questions you got? Did y'all get that? Okay. So remember, listen, if you're asked for the slant asymptote, you got to do the whole long division. If you were asked for the equation of the line that the slant asymptote, that's a new one, right, is parallel to, then we just look at this and we would have gotten y equals 3x. These are clearly different lines, right? This is not the slant asymptote, but this tells me that the slant asymptote has a positive slope. So if I'm talking about end behavior, then that's all I really need. I'm not trying to graph it and put it in the right spot. Okay, we good on that? All right. Okay, so let's look at 7. We're going to find the equations for any asymptotes in the graph. All right, so the first thing I need is the factored form. In the numerator, I'm going to go ahead and factor out the GCF up here. All right, and then I can't write small enough in there, so I'm going to put g of x out here. And so this is going to give me x, and then get x and x. The 12 is negative, so the signs are opposite. What would be my positive number there? 6. Good, so 6 and 2. And then the denominator, x and x. The 6 is positive, so the signs are the same. And these would have to be positive, positive. What are my numbers? 1 and 6. Good. Okay. Yeah, do better next time, guys. All right. Now, nobody asks me for the holes, right? But do I need to find them anyway? Yes. I'm going to mark it out, right? And then I'm going to write it down. I know that they just said asymptotes, but I'm going to go ahead and say I have a hole at x equals -6. I don't care about the y value or anything, but in case it comes up later in the question, I don't forget that it was ever there, all right? So then g of x is equal to x times x minus 2 over x plus 1. All right, so now I have the reduced version. I got rid of that point discontinuity. So I have a vertical asymptote at x equals what? -1. Okay, top heavy, bottom heavy, or tied in degree? So tell me about a horizontal asymptote.
-2.
There is the slant asymptote. Very good. It is top heavy, so this answer is none. Okay. Bottom heavy is 0. Tied in degree is the ratio of those two. Okay. So now I want the actual slant asymptote. It doesn't say the line that's parallel to the slant asymptote. So I'm going to need to do long division. I could do it with the original version, but that's yucky. I mean, it wouldn't be that big of a deal, but it's still ugly. So I can do it with this, but I need it multiplied together to make that happen. So I need to multiply this together and get x times x. I'm just rewriting the same thing. Sorry. I get x squared minus 2x over x plus 1. Okay. Then I'm going to divide. I'm going to put x plus 1 out here. Divide that into x squared minus 2x. What else do I need to put?
0.
Yes, plus 0, because you need a placeholder. Okay, for any missing terms, you have to have a placeholder. All right, so then do x squared plus x So that'll be negative 3x plus 0, negative 3. So you get y equals x minus 3. These two cannot exist at the same time. Horizontal and slant asymptotes, you have one or the other, or maybe neither, depending on what it is, but you can't have both. Okay. What questions do you have?
None.
Questions?
Is that the factor form?
This is the fact. Yeah, so technically, like, this is the factored form, this is the reduced form. But I mean, well, you really have to write them both. So just have them both there. Okay. All right, let's look at some multiple choice questions and how you're going to be asked this stuff. So this says let d of x equal this function. Which of the following of the graph is correct? All right. So before I do anything, the first part of this is horizontal or slant asymptotes. Is this top heavy, bottom heavy, or tied in degree? Top heavy. So what can I eliminate? Yeah, A and B, the two that talk about horizontal asymptotes, right? Now I need to factor the denominator. So d of x is equal to, rewrite the numerator, and then I'm going to factor this. This would be minus and minus, and my numbers would be what? 1 and 1. Okay. So then I can cancel these whole. So one slant asymptote and one whole?
Yes.
Yes? Oh, what?
Yes.
Answer C? We're confident?
Because D
How many people don't agree? You're it. Okay, tell me why. Listen. Shh. Yeah, look at that. What's that? Right? Okay, so listen, this is why I tell you to write this stuff down, even if nobody's looking at your work. Because if you'd have done what I've been trying to get you to do, you got a hole at x equals 1, and then you have a vertical asymptote at x equals 1. Can they exist at the same time? No. The VA wins. That is not your answer. Your answer is D. Good job, guys.
Because you made us write the alphabet thing.
Mm-hmm. Yep. And then zeros.
He was right. He disagreed with me.
Yeah.
That's the only reason he had.
No, I don't think so. All right. Now we're going to sketch a picture from the limits. Okay. All right. So if I have a limit as x approaches infinities, those are end behavior, way out there at the ends. If my end behavior is approaching an infinity, do I have a horizontal asymptote? No. Because if I have a horizontal asymptote, let's say I have here one here at 2 or whatever, then the limit as x approaches infinity, we'll call this g of x, this is different, would be equal to 2. Because it would look like this, right? I'm not approaching a number, I'm approaching an infinity. So I can't have a horizontal asymptote. What would I have? No, because this is end behavior. Vertical is middle behavior. End behavior, what's going to make me go to the infinities? A slant asymptote. Listen again. Listen. If you are talking end behavior, your end behavior is your horizontal or slant asymptotes. Those are your only options. If you're approaching a number, it's a horizontal asymptote because you're approaching 2 or whatever it is. If you're approaching an infinity, it's a slant asymptote or a parabolic or whatever. But like I said, we're not really getting into those. So here, because it says as x approaches infinity, f of x is approaching negative infinity. It looks like that. The limit as x approaches negative infinity, we're approaching infinity. So my line looks like this. And that's very helpful, right? That's how I know my slant asymptote has a negative slope. Okay, we good with that? Had to go backwards on that one? All right, now, my limit as I approach negative 1, so as I approach negative 1, I'm approaching negative infinity on both sides. So what's happening at negative 1? Vertical asymptote. What if I had the limit as x approaches negative 1 from the left of, we'll talk about g of x again, and I said that that is equal to 4? What would that be? A hole. When you have middle behavior and you're approaching a number, you're either approaching a hole or a vertical asymptote. Vertical asymptote will give you infinity answers. A hole will give you the y value of your hole. Okay. So I know then that I have a vertical asymptote at x equals -1. Okay, so let's graph that on there. We've got a vertical asymptote here at x equals -1. I know I have a slant asymptote. I know the slope is negative. I have no clue exactly what the slope is or what my y-intercept is, right? I don't have any of that information. So I just need to draw a slant asymptote in. That's the best I can do. So draw a slant asymptote in. Because I don't have any zeros. I don't have any anything, right? But here's what else I do know from this. Because I'm approaching -infinity both times, I'm approaching -infinity here. Sorry. I'm approaching -infinity here and here, right?
Oh.
As the limit as x approaches -1 from the left, we're going to -infinity. As we approach it from the right, we're going to -infinity. That's how we know that, right? And we also don't know if we cross the slant asymptote or not. So if you don't know, just pretend like you don't. It just makes your life easier. So that means this would just have to come up and go back down like that because it's approaching that asymptote. And this would just behave like that right there. Okay? Because my green lines are approaching that asymptote as we go to the infinities. Okay? What questions do you have? We good? Touch it again and it's mine. All right. This is what I was looking for.
Oh, what's that, miss?
Not with Vinny.